So in this math, we have a flow of different times in a particular section of a catchment area of 104 square kilometer, and it is due to a storm of 4 hours, and it has a constant base flow of, sorry, I missed that. That is actually 15. That is for, forgot. That is for 15 meter cube per second base flow, and you are asked to derive 4 hour unit hydrographs. So you have a flow, you got to be in in unit hydrograph. So in case of unit hydrograph, you just consider direct runoff. So you have a base flow. So let's say you have a base flow which is 15, and it's constant. So you need to find out the direct runoff. So in case of direct runoff, you subtract base flow from the total flow. So for the first time, it will be 0. So 15 subtracted by 15, and it would be 155, 58. I'll just write them, subtract it by 15, 259, 283, 220, 183, 155, 128, 1. I have few more. 109 and 89, 71, and that would be 0. So these are my direct runoff. So from the runoff, we'll find total runoff. So we'll find summation of direct runoff, and it will produce a value of 1655, maybe meter cube per second. Later, we'll find out effective rainfall per unit area. So we'll find out effective rainfall per unit area. Actually, we are interested in how much rainfall occurred. Because in case of unit hydrograph, you consider rainfall of one unit. So that might be a centimeter or millimeter. So in this case, we'll find out how much rainfall occurred. So we had a direct runoff of 1655, and it occurred for how many hours? It occurred for 3 hours or anything else. Let's see from the question. 4 hour storm. It was for 4 hour storm. And in this case, you need to find out, and direct runoff was in meter cube per second. And here you need to find out thing that is the volume, right? So in case of volume, how do we do that is, let's say this is our unit hydrograph, and let's say you have a coordinate over here, these coordinates. So we use trapezium. So what do? We multiply These are my direct runoff values in y-axis, and in x-axis, we have del t, which is time cap. So what do? We actually find out the volume for direct runoff volume by multiplying the direct runoff rate, which is 1655, and we multiply it the time difference, that is del t is equals to 2 hours here, 2, and it was for meter cube per second, so I'll bring them in seconds. So it will generate a value of 11916000 meter cube. So these are my volume for direct runoff. So I'll write volume here, and here I'll divide it with area. So I have a volume of 11916000 meter cube, and sorry, I have one more zero, and I'll divide it with area. So the rainfall occurred in an area of, it is given, that is 104 square kilometer. 104 square kilometer. To bring it in square meter, I will multiply it with 10 to the power 6. It's actually in square meter. So I'll get the rainfall depth, which is 0.11 meter. So it was for 11 centimeter. So now what I can do, that is, I will get for our unit hydrograph, if I can get the discharge direct runoff for 1 unit rainfall. But here I have got direct runoff for 11 centimeter. So I want direct runoff for 1 centimeter. So I'll divide direct runoff by 11 so that I can get the unit hydrograph for 4 hours. So I'll just divide it by 11. So I'll get 0 here. I'll get 14.36. 23.54, 25.73, just 20, 16.64, 14.09, 11.64, 9.90. I'll get 6.45 for that. Did I miss any? The order? That is 14.36, 23.54, 25.73, 20, 16.64, 14.09, 11.64, 9.9, and the later one was 8.09, and this is 6.45, and this is 0. So now I have got unit hydrograph for 4 hour. So the second question was, if a 4 hour storm produces 3 centimeter of effective rainfall, what would be the peak discharge? So now I'll get a direct runoff. I'll get direct runoff for discharge Q for 3 centimeter rainfall. So for that, I will just multiply unit hydrograph for 4 hour for 1 centimeter rainfall by 3. So I will just get 0, and I'll get 43.08, that's for 70.62, that is 77.19, that is 60. I just multiply this column here by 3, that would be 49.92, that would be 34.92, that would be 29.7, that would be, did I make any mistake? probably. Let's see the order. 43, 70, 77, 60, 49. After 49, I'll get a value of 42. So I made a mistake. It's hard to concentrate. So it was 60, fine, but it was 49.92, it was 42.27, it was 34.92, it was 29.7, it was 24.7, 24.27, 27, it is 19.35, it's zero. So this is the discharge for 3 centimeter rainfall for 4 hour. So now the next question was, what is the okay, fine, if produces what will be the peak discharge. So from here you can find out that the peak discharge was 77. So that was Q peak. Okay, fine. The next question was, if a 4 hour storm produces 3 centimeter, what will be okay, we did that. What is the peak flow for 8 hour unit hydrograph? So to get 8 hour unit hydrograph, what we will do, that is, we will lag 4 hour unit hydrograph by 4 hour, and then we will sum that and then we will divide it by 2. What do you mean? I will just lag by 4 here, lag 4 hour unit hydrograph, which is this. So how many hours I will lag, I will but that will depend on the, what is the unit hydrograph. It is 4 hour unit hydrograph. So I will lag it by 4 hours. So I'll not write anything, I'll write so this zero, this value of zero, which was for time is zero, it would be for time, it would be for time, if I'm not wrong, for after 4 hours. So it would be in case of, if I lag it, this zero, it was for 0 hour, then it will be lagged for 4 hours, so it will get in place of 4, so it will be 0, and then it would be 14.36, 14.36, and then I'll write 23.17, 23.54, then I'll write 25.73, then I'll write 20, then I'll write 16.64, then I'll write 14.09. Later, I write 11.64, then I'll write 9.90, then I'll write 8.09. I may go a bit lower to write the these which is 8.1, and then I can write 6.45. It will get extended base period, and I will get another value of 0. So it would be for 24 hour, and it would be for 26 hour. So then next thing what I need to do, I will add this column and this column. I will make a sum, and for that I will get a value of 0, 14.36, then 23.54, 54, then I will get a value of 25.73. Am I writing it correctly? Maybe no. It will be a higher value, which is, I will add 25.73 and 14.36, and for that I will get a value of, oh god, I'll get a value of 23 point, after 23.53 I'll get a value of 40.19, later the value of 43.54, 42.3, 37, 34.19, 28.28, 23.18, 19.73, 73, 15.54, 8.09, 6.45, and 0. And 0. So here you can see that base period has been increased by 4 hours. So now I will divide the summation by 2 hour. It is for 8 hour unit hydrograph. How do you get it? I just divide sum by how many times I just added them 2 times. So I'll divide it by 2. So I'll get 0 here. I'll get 7.18. I'll get 11.77. I'll get 20 point, sorry, is it 20? 20.045, 045, 21.77, 17.045, 14.14, 11.59, 9.865, 7.77, 4.045, 3.225. I've made a mistake somewhere. The order has been mistaken. 9.8665. 743. What did I mistake? So I just have made some mistake. That is, it would be like 3.225, not this, and it would be 4.045, and it would be actually 7.77, and it would be 9.865. So I just divide it. I don't know how did I make this mistake. So it would be 11.59, and it would be 14.14. What did I mistake? It would be 17.045, and it would be 21, and it would be 43. I just divided. Then for it's 20, it's 21.77. Okay, fine. So this is how you just do this math. You got to be cautious in putting the values. You may uh, um, lose the water. So these maths are pretty simple. You just have to calculate uh, more and more, practice more and more, and be focused when doing these maths, because you may make mistakes in case of putting the values or writing the values in correct places. So this is all from this section.